late joining us. We are still working toward our book, Machine Learning with Pytorch and Scikit-learn, and where we are using, we'll be using Pytorch for chapter 11 to the end of the book, which is somehow deep learning, and Scikit-learn where we are using it from chapter 1 to chapter 10, which is basic machine learning. And we discussed previously chapter 1, chapter 2, chapter 3, and yesterday we finished chapter 4. In chapter 1, we did the introduction, and chapter 2, we did a training, simple machine learning, and chapter 3 is one of the most important chapter if you want to learn scikit-learn. I will upload the videos that we had today, inshallah, for all these previous sessions, and also I will upload the code for all the lessons that we had in the GitHub page. I will also share it in our Slack so that we all have that. So we also finished building good training data set. So for any machine learning algorithm you want to do, make sure that the training data set is so good in the sense that there is no missing value. They are on the same scales as we saw in this chapter. And also you make sure that if you have categorical data, you change them into numerical value, because machine learning algorithm learn best with numerical data. And also it's good when you are doing machine learning to separate your data into training set and test set. So how much are you going to separate to be a training set? How much is going to be a test set? We discussed this thoroughly. If you missed that, I will upload the video as well. We also discuss how you can deal with the issue of overcoming what is called overfitting. So when you have a training data and you train your machine learning model and you learn that you have overfitting, now how can you deal with that? What do we mean by overfitting? It means when you train your machine learning model, it does well on the training data, but it fails to generalize on the test data. What do we mean by generalize? So for example, if I have 1,000 training data, you train the machine learning and it has 99% accuracy. Now you say, okay, let me test on seeing the data that I have not trained, maybe test data. And now you find out it has poor performance, like 50% accuracy. That is what we mean by overfitting. It memorized the training data, but it fails to do a really good job or to generalize on test data. That is overfitting. So yesterday we talked, okay, now how can you deal with the issue of overfitting? One way is to add more training data. One of the reasons why models overfit is that you use maybe a complex model, and now the model actually overfit the data. So many ways is to add more training data, or we can use the regularization parameters. What we saw yesterday, L1 like L2. Another way is basically maybe you use feature selections. You select some features and discuss others, as we saw. And we also saw yesterday how we can use assessing feature importance using random forest, where you can basically be able to see which features are important, which ones are not. So that's what we discussed so far. And today we'll start looking at the next chapter, which is chapter 5, which discusses about what we call compressing data via dimensionality reductions. Any question before we move on? Anyone with question regarding the previous section? Okay, cool. If there is no question, let's move on.
Doctor.
Yes, please.
Under regularization, okay, I'm gonna overfitting.
Yes.
That's a problem.
Yes.
But you did not mention underfitting.
Yes. So
under regularization.
Yes. So that's a good question. So he's asking us, we have two different issues in machine learning, right? We have what is called overfitting. We have what is called underfitting. So his question is, we now discuss how to deal with the issue of overfitting of the data, right? Meaning overfitting of the training data, but we have not discussed how can we deal with another issue, which is called underfitting. So what is underfitting? Does anyone here doesn't know what is underfitting? So that we explain what it is. So who can volunteer tell us what is underfitting? Who can volunteer to tell us what is underfitting, which is a problem in machine learning? What is underfitting? Falalu, you were here in our last book club. Tell us what is underfitting.
So underfitting is a situation whereby we make our model too simple that it fails to generalize the training set, so it performs poorly on the training set and performs as well poorly on the test set.
Okay, so Falalu, tell us that the meaning of underfitting is, so it means they are opposite. Overfitting is when the model performs well on the training and it does not perform well on the test set. It does not generalize. So we all understand overfitting. Now, what is underfitting? So the underfitting from the name is that it does not even capture wells on the training data, meaning it has both error on training data and test data. Or like overfitting, it is so well on the training data, but it's given us not good performance on test data. So you can see it's only one way. On underfitting, in overfitting, it performs really well on your training data, but it performs really bad on your test data. But underfitting, it performs very bad on training data, and also it performs bad on test data. So now how can we deal with the issue? One way to deal with the issue of underfitting also is we need to make the data more complex, to add maybe more features, and also to less regularization. We'll see more about that in the next chapter, where we discuss about, I think here, where we discuss about learning best practices, model evaluating, and hyperparameter tunings. I think we discussed that one. So that's good for bringing this into our table. For those that they don't know what is underfitting and overfitting, I think this is something we should be aware of. Yeah. So one way to deal with that, as we saw, is you see, for overfitting, one way to deal with the issue of overfitting is using what we call feature reduction. That is, if we have 10 features, then we can reduce from 10 maybe to 6. Then the model may not overfit, right? But if your model is underfitting, maybe you can add more features. So you can see it's opposite direction, right? It's underfitting. You can add more feature to the data set so that the model will understand more better. Or you can less regularize the model. So we will see more about, let me share a little bit on another screen so that we understand this more. Let me open my browser. Okay. Can you see my browser? Can you see my browser? Hello?
Yes.
Okay. So here is something that I just opened now. You can see this is what we call underfit. So this is our training data, and we want to do classification, right? We want to do classification. You can see the model doesn't perform really well. So this is called underfitting. So we have high training error, high test error. So you can see we have, everything, the error is high in both training set and test set. This is underfitting. Now, this is overfitting. Low training error on training data set, there is no error. Yeah, he perform, but high test error on test data you have. Now, this is what we want. What is called, the sweet spot, where our models does not, you can see still the model actually does not classify this guy, it does some error, but it does a really good job, right, to classify this. So this is what we want, the optimum, results. So this is what we want. So we generally, the general problem in machine learning is overfit, because when you have underfitting, you from training set, when you train the model on training data, you typically from the set go, you will see that you are not performing well. So it means you are underfitting, right? But the most difficult part that is overfit, because, oh, you see your model performs well on your training data, you are happy. But from the start, when the model on your training data does not perform well, you will not be happy to even try to test it on test data, right? So the most important problem that we generally have is overfitting. That is why the book at that instance, concentrate or explain more about overfitting, because this is the problem. But underfitting is not generally the case from our data, so we can easily spot it from our training data and add more features and do some other stuff. Yeah. So I don't know if I answer your question a little bit about this stuff.
It's okay.
Okay, so we will come see more about it. Okay, cool. Anyone who is question before we move on? Right. Okay. So what we discussed today is, as I said, chapter 5, and we will talk about what is building good training data set. There is some recommendation I will give you for anybody, because here we are working through a book which we solidify our understanding on concept. I will advise, give a recommendation for anyone here. There is a new course in Coursera for machine learning by Andrew NG, which is a series of 3 courses for machine learning. Let me share again my screen. So I will give you a very good stuff. Okay. Okay, can you see my browser?
Yes.
Okay, Coursera, Andrew NG, machine learning course. Okay, now if you come to this called Coursera, it's a course on it's a course on it's a website for that there are some courses that you can learn. I believe you all know Coursera. Now, the good thing about this is machine learning specialization, and this is a new course. There was previous machine learning from Andrew NG, which was basically not using Python, but this one has been revised. It was released, I think, 2 months back or 3 months back. This is in the world, I think. This is a role machine learning course in over the world by Andrew Ed. More than 10 million people have enrolled into his course, machine learning, the previous one. So this one is a revised one. This is Andrew NG is the father of machine learning. So what I'm telling you here is that our book series is like we are deepening and understanding, we are understanding more. But if you want to like a shortcut and go and get a really quick grasp of machine learning and start all other things, I would recommend this. So it's a 3-course specialization, and you can see it this. So the first course is supervised machine learning, where you can learn how to use regression classification. And here is advanced learning algorithms, where it introduces deep learning. So it introduced deep learning, but using TensorFlow, but it's good stuff. And the last one is supervised learning, where you understand recommendation system, reinforcement learning. So this is, I believe, if any one of us here try to do these 3 courses, 1, 2, 3, you will be on a good standing to actually move ahead on your own to start doing stuff. But this is not free. What I mean is not free. You need to pay, but there is a catch. You can request for financial assistance. So some of members here, for example, some of the members here, they have finished course 1. Let me see. Saminu has finished course 1. Murjagadanya, she is in course 1, and Saminu is now in course 2, but Murjagadanya is course 1. She's wrapping up. And at the end, you will get a certificate for that. But you don't need to pay any dime, any amount. You can come here, financial aid. When you click financial aid a lot, you just put some English, you know what I mean? You put, I don't have money and stuff like that. You know, I'm from Nigeria, you know, the money is too much for me. They can approve it, give you a scholarship, you can enroll and do the course. But for each course, you need to do it separately. So, and it takes 2 weeks to get approved, 14 days, 14 days. So if you apply 14 days, you get approval, and you now finish with exercise, and you get your certificate, and you can go to. But you can apply for the whole 3 scholarship at once, so that by the time you finish the first one, in fact, if you apply for the scholarship, you can start even doing the course without getting the approval. So if you apply today, you can just start doing the course without getting the approval. But you cannot do exercises. You cannot do assignments. It means you cannot get certificate. So this is it. I encourage all of us here, if you want to do that, this is really good specialization. Apart from this specialization, we have another thing, which is deep learning specialization. But as mentorship, I will urge you just to start this machine learning specialization. That's deep learning specialization. For example, natural language processing specialization. Recently, I will be launching a kind of mentorship program, REO mentorship program, where I will be leading people to learn Python. From Python, we will come to machine learning specialization. From machine learning specialization, we will come to deep learning specialization. Let me show you. And this is part of, okay, not this guy. Why is, okay, let me show you the other one, deep learning specialization, deep learning.ai. So we have deep learning specialization, you can see it. This deep learning specialization is also neural network improving. You know, we have about 4 courses. So we will, the program we're gonna launch is people will finish machine learning specialization, deep learning specialization, and we have natural language processing specialization, NLP, natural language processing specialization. You can see it. Now, these 3 program we're gonna launch, there is also for people that are using computer vision, not NLP, we have another specialization. It will be like 9 months program, and it is gonna be paid. We'll be paying people for data, and at the end of the program, any person that successfully finished this like specialization, get his certificate, will be given a laptop free for people. And amount of money, like for each one, like that finish, we give like 100,000 for each person. So this is just telling you some of my plan, but it's under the pipeline. But you guys, you can get the idea, and if were you, I can just start this machine learning specialization finish is, you know. So this is just something that anyone with question regarding the Coursera recommendations before we go back. Anyone with question? Okay, Zaradin, baka da tambaya?
But no question, doctor.
Okay, so yeah, so yes, go on.
My question is based on data camp. I started one online courses with them last week of August.
Okay.
And then actually I got a certificate. So from the first week of September, they have just stopped me from doing the course.
Why?
I have to pay some amount in dollars. So actually, I don't know if they have something like this.
But it's a scholarship because the account is by the scholarship na shi data camp din.
No, but it's a scholarship, but it's
Suba da akwai budgets din da suke ba. Anyway, we can discuss that, maybe we'll see what we can do. Python kike yi ko kuma me ko kuma machine learning?
Yes, Python.
Okay.
But I'm also interested in this Coursera. Inshallah, I will start doing something.
Python, we also have Python in our our mentorship session that we will unveil lately. We have Python also specialization. So I think the one we will do is I think I'm not sure. Okay, we have Python specialization. Python specialization. Not this one. Let me see. Python specialization. I don't know. Okay, I think it's this one that is part of the specialization. It's part of specialization. Anyway, there are tons of Python, for this. Yeah, let me see this. So, there is another thing. World Quant University, they are providing free stuff, getting certificate for data science and other stuff by World Quant University. At some point I did this one while I was starting, but yeah. So anyway, this is just to tell you some of our plan to get people from Ariwa get excited about machine learning. So we'll do like a program, a 9-month program. People to, I mean, or 6-month program, depending on people's, commitment. Python, then move to machine learning, then move from deep learning, then move to specialization, maybe NLP, computer vision, and it is going to be paid, as I said, and it is going to be comes with laptop at the end of the people that participate. Okay, so let's go back to our business. Any question? Okay. Right. So that's the recommendation about that. Let's go on to what we the business today. So in the previous chapter, what we learned is about what is called future selection techniques, because when our models try to overfit, or we have many features, we do future selection to select some most important features. And so an alternative or different ways for doing future selection is what we call future extraction. So this is what we will see in this chapter called future extraction. So what is the difference between future extraction and future selection? We will see that in a bit. So this chapter is basically, as I said, is about compressing data via dimension. So compressing data meaning future extraction to extract some stuff. And we will see two things, two approach to do future extraction. One is called principal component analysis. And the other one is called linear discriminant analysis, LDA. All these two methods are method for future extraction. The first one, PCA, is unsupervised way. The second one is supervised approach. Now, what is the meaning of these two things, supervised and say unsupervised? So we made explanation, what are these two approaches? So if we are doing supervised way, training a model, you give your features X1, X2, X3, and now you have your target, and you train a model on this data set. This is called supervised way, right? You train your model on supervised approach. But unsupervised, you don't have your target, you only have your training sample. So when we can see you train a model on this. So a PCA is unsupervised way. You just give your model the features, while LDA, linear discriminant analysis, is supervised approach, meaning it has the target and the feature, but this one doesn't have target. So these are the two methods that we will see in this chapter, PCA and LDA. So what is the future extraction? So let's look at this. So for example, here we have all our features. I have 1, 2, 3, 4, 5, 6, 7, 8, and we want to train machine learning model. It turns out that some of these features are not really important, equally important. We can discuss some of them. So you can say, okay, this feature is not important, and these are the only important. So these are the final features. So you have like 3 features and you train your machine learning model. What this means that train a machine learning model, for example, with 1, 2, maybe 8 features, it takes more time, right? And it may not give like optimal performance. Now, feature selection, you train with 3 features, you can train the model faster, and in some situation, because you select best features, it actually have optimal performance. That is feature selection. But what about feature extraction? So for example, here we have a data point, which is called machine. We can extract a features from this machine. So here we can see we have a tire, we have something like that. Now you can see this is extracting a feature, right? So this means that here in feature selection, we are discarding some features, but in feature extraction, we are extracting features from given one feature, we extract another features to learn. So you can see here now, when you given a feature called this kind of machine and you extract some features, with these features, you can train a model. You can be able to detect another kind of machine, because any machines have tires, right? Every machine has tires, so you can be able to detect, use this feature to even train a model that can detect. So this is basically the 2 different things. So we can see here feature essay can be understood as an approach to data comprehension with the goal of maintaining most of the relevant information. So unlike feature selection, most of the information here, we discard them, right? As we can see. We can see here we discard some of the features, but here we return all the features. So that is basically what are these 2. So Falalu is asking a question: why does the literature machine learning, we classify machine learning into supervised, unsupervised, and semi-supervised? Of course, it boils down to the available data set you have and you want to train your machine learning models. This is what we discussed, I think, in the first chapter of the book. We discussed about supervised, unsupervised, and other stuff. Sometimes you want to do prediction. You have this stuff and you have your target, you can do supervised. Sometimes you want to do clustering. You want to cluster your data sets, so you can do unsupervised learning to cluster your data sets. So this is something that we discussed in chapter 1 about the book, Palalu. Okay, so benefits. So why do we do feature extraction? It boosts in training speed. So for example, if you want to basically train your machine learning models with some features that are not important, you can extract some features and now have your machine learning. Improve model accuracy, a reduction in risk of overfitting, a rise in model explainability, better data visualization. So these are some of the features, advantage of that. We can also, similar to feature extraction, we can use different feature extraction techniques. So as you can see here, we can see here that, as I said here in this chapter, we're going to discuss 2 things, principal component analysis and linear discriminant analysis, right? 2 things we're going to discuss. But these are not the only 2 ways to do feature extraction. They are not the only 2 ways or approach to do this feature extraction. There are many other approaches to do that. So these are some of them. Feature extraction, we have PCA, independent component analysis, LDA, locally linear embedding, T-distributed stochastic neighbor embedding. So these are some of the different approaches to do feature extractions. But some of the best most used, widely used feature extraction method approaches are PCA and LDA. So this is why the book select these 2 techniques, PCA and LDA, to walk us through them. It's better you can see them. So I just put them here so that when you see them, and sometimes you can understand that, yeah, these are some of the approach for stuff. Okay, any question? Okay. Hajia, any question, Malama Sada?
Yes,
No
sir,
question,
my question.
No question.
Yes, go on.
Yeah.
Okay.
Yes, the previous question is, sometimes they classify machine learning into 3 different categories. They say supervised, unsupervised, and semi-supervised.
Yes.
But sometimes in the literature, you will see they replace semi-supervised with the reinforcement learning.
Okay.
Why is it so? Yes, that
Malama
was
Saada,
my
Malama
question.
Saada, can you tell us, barin tabo Saada, ita ce me reinforcement line, ta ci da ba.
Doctor.
So Falali yana mana tambaya.
Yeah.
We basically do have classification, right? In machine learning, when we say that, you can see that we have semi-supervised, right? And sometimes you can see, like they said, Palalu said, they can say, what do you say, Palalu?
Yes, supervised, unsupervised, and reinforcement learning.
Yes,
Instead of having
semi-supervised, by reinforcement learning. So the question is there any difference between this kind of two? So for number one, semi-supervised learning is, as you can see, it's not unsupervised, it's not supervised, it's semi. What do we mean in English when we say something is semi?
This is between.
Yes.
In between.
So it use small, is in somehow middle ground. It use small amount of data, of level data, to level maybe large set of level data. But reinforcement learning is different. I think is something different than I mean, comparing to semi-supervised. They are two different.
Yes, it's totally different.
Yes,
They are totally different.
They are totally
Yeah,
two different
different.
things. Semi-supervised is different thing. Reinforcement learning is different thing. So
Yes.
let me see. Let me share something. Okay. Yes. Let me share something here now.
So the question is, sir,
what
if I divide or I classify machine learning into three: supervised and unsupervised and reinforcement learning. So what kind of assumption do I make to put semi-supervised into these categories? That's the question. And if I divide, if I classify machine learning into three: supervised, unsupervised, and semi-supervised, what kind of assumption can I make to put reinforcement learning into these categories?
So yeah.
Yes.
So I think this is not a good link. Yeah. So I think
in most cases, when
go on, Aja.
Supervised, unsupervised, and reinforcement learning. So I think that semi-supervised you are talking of, maybe you keep it aside. And as semi-supervised, but it's not part of the classes of machine learning.
Which one? Which one?
Semi-supervised.
Mostly
most of the will see three classes: supervised, unsupervised, and reinforcement.
So most of the time,
ba wani semi.
Reinforcement learning
you will see it in the literature.
Yeah.
So what I'm saying, amma guda uku ake magana, ba a magana semi-supervised.
By conventions, these are the three main categories.
Yes,
you can't call semi-supervised
Mm.
reinforcement. Reinforcement is not semi-supervised.
Yes.
Because it's
Yes,
it's learning by trial and error.
So yeah, so inaga kamar yanda muke magana yanzu.
Penalty.
Yeah.
Yes.
So idan kaga misali yanzu, maybe I can go with the logic that suka bada. So misali yanzu, let's assume muna da three maybe machine learning: supervised, unsupervised. Then when you put that semi-supervised, it's just like in between putting the supervised and unsupervised then akadasu. So it may not
like hybrid.
So she reinforcement learning kuma it's just like
concept is different.
Yeah, it's just like a learning that reward positive behavior while penalizing poor behavior.
Negative, yes.
Yeah, so while penalizing negative or poor behavior, that is she reinforcement learning. So she reinforcement learning by way na magana, I think like data da kake da ita bane maybe kana da target ko I know the way you teach the machine learning algorithm, that is how she reinforcement learning is. By way kamar shi wancan muna
It's not dealing with data set, yeah.
Yes.
Generating based on what?
Real-time system.
Exactly.
Yes.
Yeah, something like that.
Perception environment.
Sensing and it sense and interpret its environment.
Exactly.
Act on it and learn on it over trial and
error. Kamar yanzu application da muke da su kamar na idan wannan driverless cars. So ai suna a daidai wannan lokacin suke lining abu na environment.
Problem
a lokacin yake learning kamar in ka dauki resource allocation na driverless car din. A lokacin yake yi, so in yayi rewarding da kyau, in yayi allocating da kyau shine sai ya zama reward, idan bai ba sai ya zama penalty. So a lokacin yake generating data din da zai amfani da shi for the training based on the environmental condition.
Okay. So Falalu, kana da mu abu ka gaya mana? Falalu. Okay, ko yayi gaba ne ko kuma baya jin. Okay, let's go back. So anybody here want to contribute to the discussion? Suleiman Umar S. Numa, you want to contribute something? Okay.
Ina dai saurare da gida.
Okay. Group din namu is just like group discussion where kowa ya faɗi abin nan din bakinsa. So this is how we learn together. So please feel free to chip in the little you have so that we learn all together. Okay.
So in a nutshell.
Yes.
In a nutshell, yanzu ni zan yi notes misali zan koyar da machine learning.
Exactly. Yawa.
Zan sa supervise, unsupervised, da reinforcement learning ne, ko kuma zan sa supervise, unsupervised, da semi-supervised.
Okay, to ina zuwa nuna maka wani abu. Ina zuwa.
Shi ne malam Falalu so yake ce semi shine reinforcement.
A'a, ba haka bane, din na san application din kowanne. Reinforcement learning yawanci muna amfani da shi wajen robotics.
To za kai Falalu. Falalu.
Na amsa.
So bari ka ga shi dai littafin nan abin da ya ce. 3 different types of machine learning ya ce mana. Supervised learning, unsupervised learning, and reinforcement learning. Shi abin da ya ce.
Akwai wanda yake echoing.
Okay, let me omit somebody. Okay, now echoing maybe. So Falalu, kana gana abin da littafin nan ya ce ko? This book says give us 3 different kind of machine learning: supervised, unsupervised, and reinforcement learning. So where wannan shine ake magana data a ciki da shi da wannan level data, wannan kuma ba level data. So shi wancan ɗayan semi supervised yana ɗan tsakiyar wa'annan guda biyu ne saboda yana da ɗan level kaɗan ba shi da wasu kuma babu. So shine yake tsakiya semi. So kaga combination ne na wa'annan two. So shi kuma wannan
baya zaman kansa kenan.
Baya da zaman kansa. Shi ba ya da zaman kansa. So yanzu idan ka je ga student ɗinka kawai ka ce musu guda uku ne tun daga abin da littafin nan ya ce shi ma.
Shikenan.
Majority gaskiya by convention wa'annan uku duk littattafai da write-ups da za ga by convention ukun nan suke magana.
Dole dai gaskiya.
In kuma wani ɗalibin naka ya ce maka guda 4 ne sai ka ce to shikenan yadda.
Saboda ni yawanci na karanta littattafai da yawa, wasu littattafan za su baka wa'annan, wasu littattafan za su baka.
Duk nomenclature ne Falalu. Wani ma zai iya zama kai ma yanzu zaka iya zama ka ce guda 4 ne tunda wancan is different yana yin combination of the two, kawai ka ce masa shi ma is yana zaman kansa. Just nomenclature ai naming ne ba wani ground abu bane a ce dole sai an abin nan class an ce a baka. So it just
Yes, yeah.
Okay, cool. I like it. So yeah, this is something good that we can, discuss among ourselves and learn together. So please, if you have any question, just pop the question and we can just discuss something like that, which is really cool. Okay. Okay. So now we finish with the questions on our Falalu on this concept. So now we have seen that we have different kind of feature extraction method: PCA, ICA, LDA, locally embedded, linear embedding, Y distributed. Now let's go and now understand PCA first. So PCA, as we've seen, is feature extraction method, and it is unsupervised, right? It has many other applications. So PCA, you may see it here as we say is feature extraction. but you will see PCA being done in many other parts in machine learning, such as data analysis and different kind of domains. So PCA can be used in other domains, not necessarily for the concept of feature extraction, but you see it in different kind of stuff. So that is about that. The main step behind the principal component analysis. So what are the steps that can be used to for us to implement principal component analysis? So what they said here is that PCA helps us to identify patterns in data based on correlation between features. So this is the main things that PCA does. Now, what do you mean by correlation between features? Now, if I have two features, X1 and X2, and these two features are correlated, what does it mean in machine learning language? If two features in machine learning are correlated, what does this mean in machine learning language? Who can help us? Anyone? Let's discuss.
Okay. By correlation, maybe from statistical view, maybe we can say that when two features are correlated, so they can be negatively correlated or positively correlated. In this sense, when we have maybe one feature on the y-axis, and maybe the value of that feature increases as the value of the second feature increases, so we can have positive correlation. So you will see when you plot the data points, you will see you can put a line maybe in between. Then when they are negatively correlated, so one maybe the feature on the y-axis decreases, the feature on the x-axis also decreases. So we have that, and we have the other part is uncorrelation, whereby we have scattered data points on the maybe Cartesian graph.
Okay. Anybody can add?
At what he has just said, when we are talking about correlation with regard to machine learning, so in principal component analysis, we are trying to find the correlations between features in order, because we have our target since we are doing machine learning. So we are trying to reduce the features, and by finding the features that are correlated, that will help us to get the best predicted value.
Okay, cool. I like the answers. Thank you very much for contributing. Let me. Okay, anybody want to add his sense?
Yes, the term correlation just refers to mutual relationship between two or more things.
Okay, good. So what about if mutual relationship between stuff like that, right?
Yeah.
Okay. Let me quickly share something we can see. So in terms of machine learning, one features, for example, when I have features in machine learning, let me assume I have machine learning. I'm doing machine learning. This is features, right? X1, X2, X3, Xp. Now, if X1 and X2 are correlated, and now I want to train machine learning model. If two features, n features are correlated, do they have effect on your machine learning model? That is the question I want to ask. Do they have effect on training the machine learning model? Negative effects?
Yes. They have.
Okay, why?
Yes, because they are parallel.
They are parallel? Okay, anyone who can tell us the, okay.
And
do
if
you think
maybe
they have
X1 increases, then X2 will also increase. And if X1 decreases, X2 will also decrease.
Okay, again, okay, good point. Anybody can also add what she says? So it means, do they have negative effect or positive effect?
They have negative effects.
Okay. So
They usually contribute to lower accuracy.
Okay, low accuracy, but okay. Let me share something about that. So so you can see this is a question in supervised learning. Why is it bad to have correlated features? Can you see that? Why is it bad? I read somewhere that if we have features that are too correlated, we have to remove one, as this may wasn't the model. It is clear that correlated feature means that they bring the same information. So it is logical to remove one of them, but I cannot understand why this wasn't the model. So you can see, like, if we say features are correlated, it means they have the same information, they bring the same information. Now, you see, they don't contribute much because they bring something the same. So you need to remove one. So look at some of the answers here. We have correlated features in general don't improve models. Can you see that? Although it depends on the specific way, but the effect of specific in different way. So since they don't improve models in general, so it's better to move them. For linear model, can you what we call multicollinearity, which is problems if you have features that are correlated, you tend to have what you call multicollinearity for linear models. For random forest can be good at detecting interaction between different features, but high correlated feature can mark this interaction. So it can lead to problem also in random forest. So more generally, this can be viewed as case of Occam's razor theory, which says a simpler model is always the best. This is what we call Occam's. This is one theory, or let me say, what is it, like a quote, Occam's razor or Occam's or something like that. The principle is this: always choose a simple solution. Do you understand? It has different kind of stuff. If you read that about the rule, what it's saying, but the main idea about this is choose a simpler solution. So you can see, like, when I have like my model with like 5 features and two or three features correlated, remove them and leave only one. Simple. That is it. So this is basically what we are talking about, feature correlation. So we can see that it's actually feature correlation is actually not good in machine learning. In general sense, we tend to remove those features that are highly correlated and works toward with models with less correlated features. Anyone want to add something before we continue?
It's just like to cite an example, as we have in our Titanic data set. We can't have maybe sex like male in word and female in word also.
Yes.
And we have again another feature that we have 0 for female and 1 for male. So we have to remove 1.
Exactly.
Specifically,
exactly.
sex in word.
Exactly. So that's that is what PCA does. PCA helps us to identify patterns in data based on correlation between features. It finds some kind of direction of maximum high variance, and orthogonal. So this PCA, there is a lot of mathematical concept behind PCA. I will urge you to read the book. We will not go through the concept. But we can briefly look at how we can just implement PCA in scikit-learn. So there are mathematical concept which is so messy. We may not look at it, but let's briefly look at this, how we can use PCA. So this is a data set we have in that we will be able to use for machine learning, which is wine data set here. You can see we use read CSV, as you know. This is how you read the data. And now here, this is the data frame dot columns. Now we assign the column names. So you can see this is the column name. So here we do assignment of the column, because when you read this first without this, let me show you here. Here what we do, because we say header is none. When we read this guy, when we have this, when we have this, you can see there is no headers here, right? Because here we say header none. So we can provide the headers because there was problem with that. So here we provide the column levels. alcohol, these are them. And now when we view them, head, in Python, head allow you to see the data set. So this is our data set. Now, how can we do some kind of PCA to remove the data? So for you to do PCA, first of all, we already know we need to split our data set into train set and test set. We already know that. So here you can see here, I said df1 iloc. So iloc is a function, is pandas stuff that can be used to subset a data set. So here, if you look at it here, okay, so let me show us here, here. Okay, here you can see that we use head. So if I, okay, let me run this guy. Okay, if I run this guy again, you can see here I have how many rows? 178 rows, right? And 14 columns. Now, if I want to divide this data set into train set and test set, we already know we can import our train set deeply. But here we can see here we want to basically text the values without the headers. Remember this last week we discussed about it. So if we want to do train machine learning model, we always don't take these levels, the headers. We only take the values, only the values. So here, this guy, what this guy does, for example, let me show you. So here, what this guy does is say, okay, this data frame iloc, which is used to do subsetting. So given the data, iloc is used to subset the data based on an integer. So here, the first thing here it means from the whole rows, right? The whole rows. Here I want to the whole rows, and now here it means from the first column from here. Yeah, because it doesn't start with this. This is 0. Now from here to end, and give me the values. That is what we are trying to take here, is that everything here daga nan wajen har zuwa ƙarshe. Bana san wannan. So let's look at this. When I run this guy, so this returns an array, right? This will return an array. But I think we can do this like this, right? PD dot data frame. I think here I can turn this. It's good, maybe less, so that we can see this as understand it better. Yes. So you can see here, I select from here. Can you see from 14.23? Can you see that to the last one, which is 12? And remember, this one is not part of our data frame. This one is Python that pandas that put this index automatically. So what I have is only this. You can see I didn't select this one because this is class level 1. What we want to predict, whether one is Setosa, this is a data set, Y, something like that. So this is why you can see here we use these values, because when we want to put our features, we use only the values. So also here the target. So you can see here I said the whole rows, right? The whole rows, and what I want is only one column, 0, which is the first column here. If we see this slide, we can see here we can change this to values. We can call this PD dot data frame. You can see this column, right? So this column is our target. So remember, I show us here when we have our data set, we have features. These are the features. This is the target. This target is only one column, what we want to predict given these features. So this is it. So you can see here, this is the target, only one column. 1 means as in Setosa, 2 means bicycular, 3 means whatsoever. So we want to train a machine learning model to predict this. Remember here in our last chapter, we made mention that if you have even class that are categorical, you need to change them into values. So that is why here from those vesicular, Setosa, they are changed to 1, 2, 3 values. You can see that. And now for those that have missed some of our sessions, we, as I made mention, if you want to train a machine learning model, we don't need to, using scikit-learn, we don't need to fit in the data set with these labels at the top. We need to remove them and fit only the values. So how do we remove only the, we only take only the values? It's by using this dot values it gives us. So you can see this is our target, and you can see this our training data. So that's what we did. X is our training data, Y is the target. And now here we want to divide this data into train set split. So here you remember X train, X set, Y train. This is how we do split, divide our data set. This is the test size. I mean the split size 0.3, meaning that the test size will be 30% and training size will be 70%. And stratify, we use random set, and this is how we divide that. So you can see this is our train set. You can see them. Now, if I remove the head, I can be able to see how many I have for the training set. I have 124 rows and 24 sample. For the test, we can see how many we have. I can see I have, what is it? X test. Okay, how many do I have? Okay, I have 53 for test set. You can see that. So this is basically just showing. I believe we all understand. Anyone with question, if you have question, please. I just want to explain it more because for some people that are not here in our previous session, but anyone with question regarding this, or you don't understand why we do something, please ask question. This is just interactive session where we understand, we learn all together. Ask question, please. Don't leave it in your, and you have some doubt. Okay, we are all correct, clear with this. Okay, so this is, we prefer our data set for training set and stuff like that. But the thing is, we want to do futurized, we want to do PCA. Now, one thing with PCA is that PCA are highly sensitive to data scaling. Meaning, if you want to do PCA, make sure you scale your data. You remember in our previous class, we discussed about future scaling. That is to standardize your data set so that it have the same scales. So who can tell us, anybody that doesn't know what is future scaling or why we do future scaling? Anybody? So that I can explain. Okay, so maybe if everyone is all right with future scaling, don't feel shy, please. This is where we all learn. So I continue to give an example is this. What do we mean by future scaling? So you can see here, I want this future, I have some values. We can see, okay, this is, I have value here, 1.9, 2.9, 17, 11, 100, 3, 2.7, 0.39, 1.68. Look at another one. The value is 1,370, 12,900. So you can see these features, the values, they are basically of different scales. So if you want to train your machine learning model, in some machine learning model, they are sensitive to the scales. If they have varying scales, they will not learn well. So the idea is to rescale this point to be on some kind of a closer value. So that is what the idea. So we, if you want to do PCA, you must scale your data. So this is what we want to do: import standard scalar, create a scalar object for standard scalar, and now we fit transform on the X train. Remember, we transform our training data set, and now you use the now we transform on the test set. We don't basically fit the test set. So we only do on training set. If you remember in our previous session, we made mention about this. The fitting transform, the object, your standard scalar here, when you fit and transform, you fit and transform, you learn, you fit and learn. So here on test set, you don't need to fit because your object C has learned everything from the data set. You just need to transform your test data. So now here, this is what we do. We transform the data. Now, finally, now you want to, we basically create, we scale our data set, which is some part of reprocessing. So let's look at how we can basically create PCA. So for you to create PCA, we need to create an object called PCA. So you can see here, so you need to import PCA stuff. Let me see something like this. I need to import, it was imported somewhere else. Let me quickly go and take this. Yep, here. No. So if we quickly come back to our session here. So you can see here, I import two algorithms, right? I import logistic regression and I import PCA. Logistic regression is used for classification and PCA can be used for selection. You remember they are all under scikit-learn. Here is under linear models because this is a model for classification, but this is for decomposition, which is PCA. So you can see here, we said create a PCA object, a number of components, you need 2 components. And now we can say, okay, PCA object, now we fit transform on training data. Remember our training data that we standardize, train data, X train data standardized, X test data standardized. Now you take that one and fit it, PCA, fit transform X train, and now you transform only the test data, don't fit it because you learn everything on the 10 data. So here we do the stuff. Now your data has been now, you have done what is called principal component analysis. It reduces some of the features. Now you can basically go now directly and train your machine learning model. So we already know here we want to train, for example, logistic regression to do the classification. We say LR logistic regression because we already imported. Here you put the algorithm you want, multi-class, random state, whatsoever, and the solver you want. If you look at logistic regression, these are some of the stuff we want. And now when we create the object for logistic regression, as we already did, then we can fit, right? We can fit on the X train PCA and Y train here. X train, remember your target, you don't transform your targets. So you can see here, what we are transforming here, also we transform only train, we transform here, you can see, we transform here the X, right? The training, can you see that? We transform the X, what that is the futures. We didn't transform the target. Can you see that? Can you see, if you remember here, we divide our data set into X train, X test. So X train and X test all came from this training data, right? For the futures. But this one, this is where we divide it into Y train and Y test. So we don't transform the target at all. When you want to do it like your future scaling whatsoever, don't touch the target because you are not, you don't want to learn from that. So that is thing you should know. So that's why here you can see we transform here the trend for standard scaler, and also we transform the test set. And finally, if we go here, we do principal component analysis, and now we can do that. And now we can plot our data set, and we can see now this is our data set here. So you can see here we have 3 classes now. You can be able to you know, classify your data into different classes. We need to stop here, and we can continue discussion more about PCA next week, inshallah. I need to go quickly here. So the main takeaway for this today session is that we introduce what is called, we come into another chapter that is called dimensionality reduction, which is called feature extraction, that we use it. And we have 2 different approaches: PCA that we're going to discuss, and linear discriminant. And PCA is unsupervised method, and LDA is supervised method. And we also discussed that the difference between feature extraction and feature selection. In feature selection, we only select some features, and in feature extraction, we create more features. And it does have some benefit. Feature extraction, it speed up, improved model accuracy, and a reduction in risk of overfitting. You can see here they talk about risk of overfitting. They don't talk about risk of underfitting. So overfitting is always the one that is most riskier rather than underfitting. And we saw that there are many approaches for using feature extraction, but we're gonna see PCA and LD, and we start seeing the PCA. And yeah, so we start discussing about PCA here, and we read our data set. We said, let's use a data set for one data set. And now we said, okay, given the one data set, this is the class level that we want to predict. These are futures, where here we saw it. And now here, if you forget your pandas iLog is basically used to subset a data frame by column or by row. So we have also lock. So you can see what is iLog. iLog is purely integer location-based indexing for selection by position. Lock, which is LOC, can use not purely integer-based. It can use what we call what do you call it? Not integer, but rather maybe string format, stuff like that. So yeah, we discussed this in our first session of Python book club, where we go through all this stuff. And here, remember I talk about values. We don't need to feed in machine learning algorithm with these headers. So we remove them. So that is why these values, it remove them. It only take only the values inside your data set and don't return the header. That is why. So this is, you can see the target, and now this is the futures. Now we said, okay, now we do trend test split. Remember, always this is how we do trend test split. You put X trend, then text, Y trend, then Y test. And now you just call your function trend test split. It will divide your data set and assign them into, assign them professionally. So you can see here, we have 1, 2, 3, 4. We have this trend test split. We divide the data into 4 classes. It will assign the first one into trend, the second one into test, the third one into this, and this one into this. And yeah, so here I just show you an example. And now we saw that before you actually do PCA, we must rescale our data. So here we do what we call standard scaler, which basically does the scaling. And here we just create a function which do the plotting. Don't care about this, don't bother about this. And we just show how you can use PCA. Very simple, right? So here you import PCA, and now you create an object for the PCA, which you specify the number of component you want. If you want to read more about PCA, you can see here n component. That is what we put. We say 2. So if you see PCA principal waye kaza ga turanci ga example kala, you can go to that. And now for PCA, it's still the same thing where how we do. Remember, that is one good thing with scikit-learn. It has consistent API. So for example, here you can see where we do scaling. We basically, because we import scalar, we create an object using standard scalar, which is SC. You can see we fit transform the trend data, then we just transform the test data. You can see this. So this, you see this structure is still the same thing when we want to do this create component analysis. You can see we import PCA, we say create an object PCA using PCA method. You can see we PCA object move, we say PCA object fit transform on trend and PCA transform. So they have the same API, consistent API. We discussed this in our previous chapter 4. And now here we train a machine learning model and do that. So that's what we have. Anyone with question before we move on? Goes tomorrow, inshallah, next week we will try to continue and finish possibly the chapter. Any question?
Yes, I have a question, but a little bit about what we have discussed. The last topic we have discussed, but it is from time series about scaling.
Right.
About scaling. It's
right.
Using scale. I have found many models for univariate, multivariate time series models. They are scaling the data. Since in time series, we are trying to use the same, we don't have like X test, X trend, or X trend, X test, Y trend, Y test. We normally in time series for multivariate or univariate, we can simply divide. For instance, we have a column X in a univariate. From the same column X, we are dividing the data for trend set and test set.
Okay.
So in that case, in case of univariate time series, so we normally, what I have found, they normally scale the data. They normally scale the data.
The algorithm or what?
When they have a data, for instance, we have in our data set, it has only one column, X.
Okay.
So we can, in time series, in univariate time series, they try to scale that data because it has different values,
okay,
which may affect the prediction. But
yes,
but since they are trying to use the same X values for train set and test set, so they are only scaling the data without fit transform. This is what they're only without fit transform. Since they are using the same from the same column, using the previous value you are using the previous value to predict the next values.
So I think there is something in scikit-learn.
This is what I have found.
Yes, yes. So let me.
Does that affect the performance of their model?
So let me show you something. So let me show you something a bit. This one here. Oh, I have something, I think. Oh, I said something. So there's an example I want to show you. So yeah, there is I don't have time to show this. Let me show you something. PCA scale. I didn't import it here. Okay. Anyway, never mind. Okay. So in scikit-learn, there is something called scale. I don't know if you mean if you not this one. Where do I
using standard scalar,
Oh, you are using it, you are talking about using standard scalar?
Yeah, using standard scalar. Yeah, using standard scalar.
Okay, so just to say something, some people may find something like this scale. Can you see what something called scale? There is no standard scalar or something like that. So this scale is also used to basically do scaling. So in some situation, you can see this function. So I thought you are talking about this. So you don't need to do all those, fit transform or so this function scale, calling it, you can see standardize a data set along any axis. So centered to the mean and component wise, something like that. So this is something that also you can see that can be used to scale your data. So here you can see we only fit the data. Can you see here?
Yeah.
So you can see here we fit the data and now here we transform. So this is more or less about fit transform. This is using 2 steps, but fit transform is this 2-step fit and transform. We merge them and now here we use what is called fit transform. That is so. So your question is your example that you are working in your you are not transforming, you are only fitting, right?
Pardon?
Your question is like in what you are doing, you are only fitting, you are not transforming the trend data. Is that right?
Yeah. Since we are from the data, we are trying to use from the same column. So some part for training and some part for test, or sometimes 3 state.
So I think
test, validation and training, test and validation.
Okay.
Sometimes.
Okay. So I think so yeah, so I'm not sure because I don't know time series actually.
Okay, so no problem. I just tried
maybe it's specific to
many models.
Yeah, it's specific to time series. I don't know anything about time series. So you are the expert. Yeah, I don't know anything about time series. I just know that time series data as the data that has the notion of time whatsoever, but I have not do something related to that. So maybe I think your data set in time series world, that is how it is done. Maybe you can check more literature and confirm from that.
Yes,
yeah.
Thank you very much. Okay.
Yeah. Anyone want to add something? Thank you very much, Zaradin, for bringing this. So it's good for us to discuss. So you can see Zaradin is practicing something in his, so he can come across many issues that he can answer. So please, you also, if you have what you are learning, try to doing practicing or something like that. Any question?
Maybe Zaradin zai ba mu lecture wata rana.
Yeah. Any question again? Okay. So I need to run. So inshallah, we see next week. Bye bye. Ciao.
Bye bye.